Namaskar students, today we are going to discuss about that topic of school mathematics which should have got that importance which it did not get. The topic is called Surds. Now to start the discussion about Surds, one must know the definition of algebraic numbers, and to know the definition of algebraic numbers, one must know the definition of algebraic equations. So what are algebraic equations? Now before going on to know the definition of algebraic equation and algebraic numbers, let us write few equations with one unknown. Suppose you have an equation of 1 degree with one unknown, a0x plus a1 equal to 0. Then what will be an equation if it is extended to a 2 degree equation? A0 x square plus a1 x plus a2 equal to 0. Now extending this to a third degree equation, a0 x cube plus a1 x square plus a2x plus a3 equal to 0. Similarly, extending this one to a fourth degree equation, you can write a0 x to the power 4 plus a1 x cube plus a2 x square plus a3 x plus a4 equal to 0, and so on. You can write an equation of 5th degree, 6th degree, and so on if I tell you to write. Now over here, whenever I am telling an equation of 1 degree, 2 degree, 3 degree, 3rd degree, 4th degree, you must always keep in mind the coefficients of the highest powers of x which is existent in a particular equation should be non-zero. Over here the coefficient of highest power of x is a0. Over here the coefficient of the highest power of x is a0. Similarly over here also a0, over here also a0. Now if this a0, suppose you are considering a third degree equation, if this a0 becomes equal to 0, then the term containing x cube vanishes. So this one now becomes an equation of 2 degree, provided a1 is non-zero. So whenever you are telling an equation of a particular degree, then the coefficient of that power of x should be non-zero. So the first consideration for these type of equations are that a0 should not be equal to 0. Now these category of equations will be called algebraic equations if these equations satisfy one particular condition. And what is that condition? All the coefficients of x which you are seeing, that are ai's, must be particularly integers. Okay, if all the coefficients what you're seeing over here are particularly integers, then these category or this class of equations are termed as algebraic equations. And the solution to these equations, okay, suppose the solution to the first equation will be minus a1 by a0. Similarly, you know how to solve a second degree equation, you know how to solve a third degree equation provided the coefficients are given to you. So the solutions of these algebraic equations are called algebraic numbers. So to sum up the discussion, these type of equations will be called algebraic if the coefficients are integers, and the solutions to these algebraic equations are termed as algebraic numbers. Now in the other way around, if I tell you what is an algebraic number, you can now easily tell a number will be called algebraic if it is a solution of any algebraic equation. Okay. Anyways, see, any real number can be categorized into two types, rational or irrational. You give me any real number, I can particularly tell you this real number is either a rational number or an irrational number. Now see, what are rational numbers? Let us recall the definition of rational number. Any number which can be written in the form m by n, where m and n are integers with an added condition that n should not be equal to 0. Then these type of numbers are called rational numbers. For example, 0, 1, 1 by 2, minus 5 by 8, etc. And what are irrationals? Irrationals are those numbers which cannot be written in the form m by n. For example, root 2, root 3, minus 1 by root 5, Pi, we all know that is an irrational number. E, we all know that is an irrational number, etc. Now see, over here, if I tell you root 4 is rational because root 4 can be written as plus minus 2, which is again a rational number. So, all square rooted numbers are not irrational. Any square rooted number, if it cannot be expressed in the form m by n, where m and n are integers with n not equal to 0, then that type of numbers, those type of numbers will be called irrational numbers. Now the question is, among these two category of numbers, which numbers can be algebraic? See, for the rationals, it is an open and shut case. What did I tell you? What did we discuss? Any number which can be a solution of an algebraic equation will be termed as an algebraic number. Let us see if the numbers of the form m by n can be solutions of any algebraic equation or not. See, for this equation particularly, nx minus m equal to 0. See, over here you have one unknown, m and n both are integers. Okay, so this equation can be called an algebraic equation. What is the solution of this equation? See, x equal to m by n. If you put x equal to m by n, this equation gets solved. Both sides becomes identical. So you can tell the solution of these type of equations are of the form m by n. Now m by n is again of the form of a rational number. So any rational number you give, that can be expressed as a solution of an algebraic equation of this form. So in other words, we can tell that any rational number is an algebraic number. But what about irrational numbers? Can we tell the same thing for irrational numbers? Can all irrational numbers be termed as algebraic numbers, as we can say for rational numbers? Let us see. See, suppose root 2. Root 2 is irrational. What if I write an equation x square minus 2 equal to 0? This is an algebraic equation. The coefficient of x square is 1, integer. Over here you have minus 2, that is an integer. So it is an algebraic equation. No doubts about that. What is the solution of this equation? Solution of this equation is plus minus square root of 2. So one of the solutions of this equation is root 2. So root 2 can be termed as a solution of an algebraic equation of this form. So root 2 becomes algebraic number, because algebraic numbers are those numbers which can be represented as solutions of any algebraic equation. Similarly, you can tell for root 3 also. See, for root 3, x square minus 3 equal to 0. Solution of this, you can tell root 3 is the solution of this equation. So root 3 is also an algebraic number. Similarly, minus 1 by root 5 also you can compute that. Suppose you have 5 x square minus 1 equal to 0. See over here, x square, from here you can tell x square equal to 1 by 5 or x equal to plus minus 1 by square root of 5. So minus 1 by root 5 is a solution of this algebraic equation. So minus 1 by root 5 is also an algebraic number, being an irrational number. So we can see rational numbers are definitely algebraic numbers. Irrational numbers are also becoming algebraic numbers. But are all irrational numbers algebraic? Let us see the cases of pi and e. See, for pi, you know, pi and e are irrational numbers which can be represented decimally, and the numbers after the point, decimal point, those are unending numbers, unending sequence of numbers. Now, if I tell you pi has to be a solution, then you have to write like this: x minus pi equal to 0, or x minus e equal to 0. Solutions of x minus pi equal to 0 is x equal to pi. Solution of x minus e equal to 0 is x equal to e. But are these equations algebraic? No, because for being an algebraic equation, all the coefficients must be integers. Over here, see, pi, e, these are not integers. So these two are not algebraic equation. In fact, you cannot find any algebraic equation that will fit these two as their solutions. So there exist some irrational numbers like pi, e, and the terms which you can build up using pi and e, which are not algebraic numbers. Also, there exists some category of irrational numbers which can be told that yes, this category of irrational numbers are algebraic numbers. So again, to sum up this discussion, this part of discussion, what we have concluded is that for real numbers, it can be categorized under two categories: rational and irrational. All rational numbers are found to be algebraic numbers. All rational numbers. You give me any rational number, that is an algebraic number. But for irrational, there exist two divisions. Some of the irrationals are falling under the category of algebraic numbers, and some of the irrationals are falling under the category of non-algebraic numbers, which are called transcendental numbers. Okay, let us not go into that discussion. Let us concentrate on algebraic numbers only. So these part of irrational numbers which are algebraic numbers are called surds. These irrational numbers which are algebraic numbers are specially termed as surds. So in other way, we can tell a number, if it has to be a surd, it must be both irrational and algebraic. Let us see a few examples and try to categorize whether the numbers are surds or not. 1 root 7 minus 6 minus 8 by root 2 0 1 by root 3 cube root of say 8 and suppose cube root of 11. Let us see whether these numbers are surds or not. See, for being a surd, the number has to be irrational and algebraic both. Foremost, the number has to be firstly irrational. 1 is not an irrational number. Minus 6 is not an irrational number. Let us leave this number. We cannot say immediately about this number. 0 is not an irrational. Cube root of 8. What is cube root of 8? Cube root of 8 means 2. This is actually 2. So this is not an irrational number. 2 is a rational number. Now, root 7. Can root 7 be an algebraic number? Let us see. If it has to be an algebraic number, it must be a solution of some algebraic equation. See, for this equation, x square minus 7 equal to 0, we can tell root 7 is the solution of this equation. So this is an algebraic equation. So root 7 is an algebraic number also. Hence, this is surd. So this is surd. What about minus 8 by root 2? Minus 8 by square root of 2. See, minus 8 by square root of 2 means actually this is root 2 to the power 6. This is actually minus 8 means what? Minus 8 means minus of root 2 whole to the power 6. So if you do a by root 2, that is actually minus square root of 2 whole to the power 5. Or in other words, you can tell this is minus 2 to the power square root of 2 means 2 to the power half, half to the power 5, that is 5 by 2. Minus 2 to the power 5 by 2. Is there any algebraic equation that can have minus 2 by 2 to the power 5 by 2 as the solution? Let us see. See, you can have this equation x square minus 2 to the power 5 equal to 0. See, x square minus 2 to the power 5 equal to 0, this is an algebraic equation. Okay, it is actually x square minus 32 equal to 0, this is an algebraic equation. What is the solution of this equation? X equal to 2 to the power 5 to the power half plus minus. So it is plus minus 2 to the power 5 by 2. Hence, minus 2 to the power 5 by 2 is the solution of this equation, which is an algebraic equation. So this one also becomes an algebraic number. This is an irrational number, no doubt about that. See, this is an irrational number. Minus root 2 whole to the power 5. You cannot write minus root 2 whole to the power 5 in the form of m by n. So this is not a rational number. It is an irrational number, and it is an algebraic number also, which we have seen. Hence, this is a third. So this is a third. Similarly, you can test 1 by root 3. See, 3x square minus 1 equal to 0. Solution of this is 1 by square root of 3. One of the solutions is 1 by square root of 3. So this is an algebraic equation. Algebraic equation solution is 1 by square root of 3. So this is an algebraic number. This is an irrational number also. So irrational plus algebraic, this is a third. Okay, this is also a third. What about this? This is also a third. See, x cube minus 11 equal to 0. What is the solution of this? So x cube equal to 11. Hence, you put cube root of 11 in place of x, you get an identical form in both sides. Hence, cube root of 11 is the solution of this equation. This equation is algebraic. See, the coefficients of this equation are all integers. X cube's coefficient is 1 integer. Over here you have minus 11, that is an integer. So this is an algebraic equation which has a solution cube root of 11. Cube root of 11 is also an irrational number. So cube root of 11 becomes irrational plus algebraic both. Hence, this is also a third. Okay. Now, anyhow, if you would have had numbers of this type, suppose 2 to the power pi or pi to the power e. See, these type of numbers, you cannot find any algebraic equation that will have solution of these form. Any number involving pi, e, these type of numbers, even though they are irrational numbers, these type of numbers are not algebraic. Hence, these type of numbers will not be surds also. To be a surd, it has to be both irrational and algebraic. See, there is an observation to be made over here regarding the definition of surd. As of now, we have concluded that any number which is irrational plus algebraic both, that is called a surd. And for examples, we have taken these numbers and we have found that, okay, these numbers are actually surds because all these numbers are irrational plus algebraic both. Now let us observe the form of these numbers. See, root 7 can be written as square root of 7 by 1. Similarly, this can be written as square root of 2 to the power 5 by 1 means 32 by 1. This also can be written as cube square root of 1 by 3. Similarly, this also can be written as cube root of 11 by 1. Can you understand? There is a pattern of the numbers which are actually surds. See, by looking at these numbers, we can generalize and tell any number which can be written as nth root. See, square root, square root, square root, cube root. Similarly, you can have a fourth root also, fifth root also, which are irrational plus algebraic both. That is a surd. Okay. So, in general terms, we can tell any number which can be written as nth root of some number of the form, say a by b, where obviously a and b should be positive integers, because uh, obviously b cannot be equal to 0. If b becomes equal to 0, then it becomes undefined. Okay, so b is non-zero. Now if a becomes equal to 0 or negative, what happens? You have a negative number inside a root, that becomes a complex number, imaginary number. So we are not going to consider those type of numbers. So for as of now, a and b both should be positive integers. Now, a cannot be equal to 0 also, because if a becomes equal to 0, then the number itself becomes equal to 0, which is a rational number. So no question of being a surd. Okay. So for being a surd, see, these numbers can be represented in this form: nth root of a by b, where a and b are positive integers. So here we arrive at an alternative definition of surd. Any number which can be represented in this form is also called a surd. Now just a word of caution over here. See, you can tell, okay, then if we take a equal to suppose 4 and b equal to 1 and n equal to 2, is this a surd? No, this is not a surd. Why? Because if a is just put the numbers over here, what it becomes? Nth root of a by b means then square root of 4 by 1, that is equal to plus minus 2. So it does not remain an irrational number. Okay. So the first and foremost thing remains same. Whatever may be the form which we are discussing, the number firstly has to be an irrational number. If the number is irrational, then go looking for the other qualities of that number, being it algebraic or not, or the number is in this form or not. So the first thing prevails, the number has to be irrational at any cost to be a surd. So my dear students, this is all what we had for today regarding the introductory discussions about surds. Now surd is an important portion of school mathematics, which is nowadays being neglected, but I believe this is a very, very important portion to learn and to practice. In the coming few videos, we shall see a few more problems, important problems regarding surds that might be helpful in your board examinations. Till then, goodbye.